Hello and welcome. My name is Kaleb Lovingier, and today I will be presenting my final microbiology presentation. This presentation will be on psychedelic microbes as well as the relationship between psychedelics and microbes and the effect on society that these microbes have. So to begin, it is important to talk about a group of fungi called ergot fungi. And these fungi are called ergot fungi due to the fact that they produce compounds called ergot alkaloids. And we can see these on the right of the slide. They include an ergoline ring as the backbone, which is a type of indole, and we can see on the bottom right that we have lysergic acid, which is a precursor to lysergic acid diethylamide, also known as LSD. And the different fungi present within these ergot fungi group include different genuses like Claviceps, Penicillium, and Aspergillus. So here we can see the ergoline ring, that is the backbone to the ergot alkaloids, and as well as the three different classes of ergot alkaloids where we have clavines, ergoamides, and ergopeptines. And we can see the various R positions and the substitutions that make the various compounds within these classes of ergot alkaloids. So regarding this group of microbes, the ergot fungi, there are a number of different plants that they can grow on, and we can see some examples of this on the right. And the word ergot actually has its origin due to a French word that means spur. And in picture A, we can see one of these little black spurs that gave ergot fungi their ergot name. And it is important to note that many different plants have heritable fungal symbionts that produce these bioactive ergot alkaloids. And due to their pharmacology, they have the ability to produce anti-herbivory effects where they will deter animals from eating the various plants that have the ergot fungi due to the psychoactive effects of the ergot. So on the right of this slide is a somewhat cramped diagram, but I do encourage you to pause the video and go full screen in order to better view the detail here. This details the ergot alkaloid biosynthetic pathways, and on this image you can see the various enzymes at play as well as the various species of microbes that can be used to produce these compounds. So to note some important historical events that have to do with ergot alkaloids, uh, ergot alkaloids, when ingested by humans, often through contaminated bread that has had uh, grains used for it that had ergot fungi, and this causes something called ergotism, and this ergotism is likely the cause of the Salem witch trials, where the affected individuals were perceived as being witches due to the strange behavior and visions brought on by these various ergot alkaloids. Similarly, in northern Norway, in a place called Finnmark, there were similar witch trials where many individuals who came down with ergotism were perceived as being witches and were then put to death. So some more history about ergot alkaloids. Ergot alkaloids extracted from these microbes have been used historically in obstetrics and gynecology due to the fact that they can have anti-hemorrhaging effects during labor. And although they're not used in developed countries that much anymore, they can still play a significant role in developing countries due to the various pharmacology that these ergot alkaloids demonstrate. Regarding the relationship between psychedelics and the human gut microbiome, it has recently been discovered that ingesting psychedelics will have effects on the composition of the human gut microbiome, and these demonstrate the potential to effectively treat and often resolve or cure various autoimmune issues or disorders due to the psychedelics targeting both psychosomatic symptoms as well as various maladaptive stress responses, often caused by inflammatory pathways. And the immune system is also modulated directly by the ingestion of these psychedelics. And a study from Insera et al. In 2022 found that LSD decreased Shannon alpha diversity of the gut microbiota and changed the abundance of various bacterial taxa. So one example of a microbe that can be used to produce ergot alkaloids is the microbe Penicillium citrinum. And we can see an image of a culture of this growing on an agar plate on the right of the slide. And recent studies by Shahid et al. Has found that these ergot alkaloids can be cost effectively biosynthetically produced by Penicillium citrinum, and due to the cost effectiveness and ability to produce large amounts of these drugs, they can be used on an industrial scale. So the future of drug production likely lies within custom microbes where we implant genes to specifically produce various drugs. So to further detail some microbes that can be used to produce drugs, recently E. coli has been used to produce the compound psilocybin, which is 4-phosphoryloxy and N-dimethyltryptamine. This can be seen on the bottom left, and it is a prodrug to the psychedelic tryptamine called psilocin, which is also referred to as 4-hydroxy dimethyltryptamine. And this genetically modified E. coli was able to produce 1.16 grams of psilocybin per liter of culture, which is a tenfold increase on any attempt previous.